When you run compute services at scale, issues are bound to happen. The real question is, how quickly can you understand and fix them? This is where AI can cut through the noise, bringing you the right signals so that you can start your day with critical issues already investigated. Azure Copilot Observability Agent, powered by Azure Monitor, can run autonomously with knowledge of your environment, application topology, its dependencies, and typical patterns. It monitors alerts streaming into Azure Monitor, triaging and correlating related alerts into issues requiring your attention so that you experience less alert fatigue and noise. The agent investigates critical issues to determine the root cause and then recommends mitigation steps. Let me walk you through how you can use Observability Agent to your advantage as you work. Using Azure Monitor, I can observe my app across tiers. The app map shows me the topological view of my app. It's a multi-tier app with a modern microservice backend hosted on Kubernetes with a SQL database, Redis cache, and more. The app also has an agent built in Microsoft Foundry. And with the new Foundry capabilities, I can also observe how it's performing from operational metrics, including agent runs, Gen AI errors, tool calls, underlying models, and token consumption. And scrolling up, we can even view traces with Gen AI errors and see a list of traces. I'll look at this one with 93 items. And if I click in, I can see a trace view of all the agent's activities with direct integration into our existing backend APIs through an MCP server. This is where Azure Monitor and unified logging is foundational to connecting the dots for a more complete view of the health of your service. It unifies telemetry in real time across the stack using OpenTelemetry, as well as native integrations with Azure services, and normalizes those signals into a consistent schema. And because everything shares the same data foundation, it's easy for either you or the observability agent to move instantly from insights, such as failed requests, to more details across different failure categories, which can be drilled into and queried further without having to stitch anything together. So this way, even though there are several teams involved across app and infrastructure managing my app, everyone shares a common operational view to keep it operating smoothly. In fact, let's go back into Azure Monitor and see how my app is doing, specifically my agent. This time, I'll start in our agent alerts view. It looks like my agent is experiencing some errors. I'll choose this alert to view additional details, and this is where you can invoke the observability agent using the investigate button. Importantly, once you have Azure Monitor running in your environment, there's no setup needed. So now I have the agent open, let's start the investigation. Now, when invoked for the first time, the observability agent will learn about your app, its topology, patterns, baselines, and more. In this case, the agent already has deep knowledge of my app, so it launches directly into an investigation. It's able to correlate and reason across signals spanning the full application stack, logs, metrics, alerts, application health, and ML-detected anomalies to pinpoint the root cause of the incident. It plans, executes, backtracks, runs multiple queries, and validates or disproves hypotheses, just like a human expert would. After completing the investigation, Observability Agent produces a detailed report with its findings. Now, in this case, it's discovered failures when the agent hit the MCP product catalog, where the backend telemetry shows the underlying failure was a SQL execution timeout. We can see a consistent timeout pattern with 117 failed SQL dependency calls. It's ruled out any issues with the Redis cache and has determined that there was no SQL outage. Instead, SQL metrics show a small saturation window at the incident start, which dropped after the initial spike, which would have led to connection failure. And it also charts its findings visually with search failures, latency spikes, failures by dependency, and CPU and DTU spikes. And back on the left, we see it's recommending what can be done next, including how to improve querying and code, as well as monitoring. Now, at this point, you can either start a new investigation or build off the observability agent's findings. I want to investigate further. So there are a few things that cause spikes like this. I'm going to clarify if our SQL Server saw a spike in traffic leading to timeouts. The observability agent responds quickly and notes stable to moderate SQL volume with many of the details we saw earlier. This time, though, it's found the root cause. It appears that an expensive query consumes significant SQL CPU resources. Now, I'm also concerned about token usage during the incident, so I'll ask the observability agent to check for anomalies. And after it's done its analysis, the agent rules out my hypothesis there too. So it's easy to collaborate with the observability agent in the context of the incident. You can even ask the agent to rerun the entire investigation with additional instructions if you need to. Next, I want to create an issue that captures the progress of the investigation. I'll keep all the details and agree to share the agent chat around the issue so that it can be viewed by others on my team, which lets you hand off the issue to a colleague without losing context. The issue will retain the history of the incident, so no one has to start from scratch. And in fact, this becomes a shared case file for the investigation. So I just walked you through a manual flow for how you can use the new observability agent as you work. Next, let me show you how you can get the observability agent to work alongside you autonomously on your behalf with a new capability in public preview. Either from the marketplace or Azure Monitor, you can create a new observability agent resource. But first, you start by giving it a name, select the region and your Azure Monitor workspace. Next, you'll point it at your application insights resource. We'll use our CT agent from before. And then you can configure whether you want the agent instance to run autonomously on auto-created issues to provide root cause analysis and next steps. From there, I just review and confirm. The observability agent will then learn about your application to establish deep expertise and knowledge of your environment and preserve it in the agent instance. And if an alert arrives, the agent creates an issue automatically and correlates any additional related alerts into that same issue before launching an investigation. Now, once an investigation is underway, the observability agent notifies you, for example, via email, with background on the detected issue. And from there, you can review the overview and look at the associated alerts. And as you can see, in our case, the observability agent was able to use deep agentic reasoning to correlate separate alerts, both for the agent in this application and for the backend APIs invoked independently, and then bring them together into a single unified view. This significantly reduces the alert noise. Now, this correlation is also important for issue triage, because individually, these alerts might have lower severity, but when correlated, they increase the overall severity of the issue. And clicking into the Observability Agent tab, we can see that the investigation is complete. This is a comprehensive report like we saw earlier with its analysis, corresponding chart visualizations, and recommendations on what to do next. Now, as you set up agents, you can also customize them with your own instructions to prioritize what's important. So if we go back to where you create a new agent instance, here's where you would add specific instructions written in natural language. For example, you can tell an agent to group certain alerts and prioritize the ones that should always trigger an issue, so that its autonomous behavior matches how your team operates. So that's the power of Azure Monitor with the Azure Copilot Observability Agent, which together turn alerts into fully investigated issues with clear, actionable insights. By correlating signals across your entire stack, it helps you move from detection to root cause to action faster and without losing context. The result? Less time triaging, faster resolution, and more resilient systems at scale. To learn more, visit aka.ms/observability agent. Keep watching Microsoft Mechanics for the latest tech updates, and thanks for watching.